Okay, good morning. So we're doing section 5.3b. So you have a sub today. I'm counting on you all to be good for the sub. So we started this table last time, and we did actually all of this for sine theta when you were with me. We didn't fill out the whole table, but the majority of the table. So I'm going to fill that out with you. And then we're going to pause on the screen. I'm going to fast forward, but I'm going to ask the sub to pause so you can finish completing the table after I've done the first column. So I'm going to fill out the first column with you, and then I'm going to have you guys try to do the second or the remaining columns on your own. And then the next screen actually has the answers. Okay? So let me get a pen. We'll use red. Okay, so first of all, remember sine is y over r. And I've included a copy of the unit circle over here, right? And remember, this is x, this is y, and then this right here is the radius, and that radius is what? 1. So for all of these are x, y, and then r is 1. So here this is x, this is y, and r is 1. And then x, y, and r is 1. And here x, y, and r is 1. Okay, and so sine is y over r. Let's go ahead and just write all of these down. Cosine, remember, is x over r. And tangent is y over x. And cosecant goes with sine, so that would be r over y. And secant goes with cosine, so that would be r over x. And then cotangent goes with tangent, so that would be x over y. Okay, so we're going to start at negative 2 pi. So negative 2 pi is if I started here and went clockwise. So I can't really draw a circle on this, but if I went clockwise all the way around, that would be negative 2 pi. But if I went around clockwise, I'd still end up here at 1, 0. So my y value is going to be 0, and my r is 1. So this is going to be 0 over 1, which is 0. Okay, negative 3 pi over 2. Well, this is 0 and 2 pi, and this is positive 3 pi over 2, but this is also negative pi over 2. And this is negative pi and positive pi. And then this is positive pi over 2, but it's also negative 3 pi over 2 if I'm going around clockwise, which negative means to go around clockwise. So if I end up at negative 3 pi over 2, then I get my y value, which is 1, and my r value, which is 1. So I get 1 over 1, which is 1. And then negative pi would be just going around counterclockwise here, and that would also be y over r. So y is 0 and r is 1, so this would be 0 over 1, which is 0. And then at negative pi over 2, that would be down here at negative pi over 2, or positive 3 pi over 2, right? And it's y, which is negative 1, over r, which is 1, so negative 1 over 1, which is negative 1. And then 0, now instead of going clockwise, we're going to go counterclockwise now because all the rest are positive. So 0 is y over r, so y is 0 and r is 1, so 0 over 1, which is 0. Okay, do you guys see any pattern here? We have 0, then 1, then 0, then negative 1, then 0. So what do you think pi over 2 is going to be? Yep, it's going to be 1, but to double check, it's going to be y over r, so 1 over 1. So 1 over 1, which is 1. Ooh. Okay. It's not liking that. Okay. Hold on, let me erase this. Okay. And get the pen back up. Okay. That was weird. Okay, so 1 over 1, which is 1. And then pi is going to be y over r, so 0 over 1, which is going to be 0. Okay, so now, hopefully really now you can see a pattern. It looks like it's 0 every other one, and then it's 1 or negative 1. So we had positive 1, so this one should be negative 1. But if we double check it, 3 pi over 2 is right here. And that's y over r, so negative 1 over 1, which is going to give us the negative 1. And then at 2 pi is back here again, right? So that's 1 over, or 0 for y and r for 1, so it's going to be 0 over 1, which is going to be 0. Now, if you're counting pi over 2's, this is 1 pi, this is 0, this is 1 pi over 2, here's 2 pi, I'll make a mark. This is 1 pi over 2. Ay, ay, ay. Okay, so this is 1 pi over 2, this is 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi, then 5 pi over 2. So this is back here at 5 pi over 2. So 5 pi over 2 would be y, which is 1, over r, which is 1, so 1 over 1, which is 1, 1. And then 3 pi, well, this is 5 pi over 2, so this is 6 pi over 2, which is really 3 pi. So this is 0 over 1, so just 0. And then this was 6 pi over 2, so this one's 7 pi over 2, so y would be negative 1 and r would be 1, so negative 1 over 1, which is negative 1. And then finally 8 pi over 2 right here, which is really just 4 pi. And that would be y over r, so 0 over 1, which is 0. And then let's just make sure. Every other one should be 0, so let's see, 0, 0, 0, 0, 0, 0, 0. And then alternating positive and negative 1, starting with positive. So positive 1, negative 1, positive 1, negative 1, positive 1, and then negative 1. Okay, so I'm going to ask that the sub pause this right now for you guys to complete the table. When you're done, then she'll restart this and it will go to the next slide. Okay? I don't know about that. What the happened here? We got... Okay, so I'm going to go to the next screen. Okay, good. So here's the next screen. Hopefully you filled out that table. If you got it wrong, then maybe discuss it with your table partners or, your elbow partners and see if you can figure out where you went wrong. So I want you to notice, so there's always a pattern. So cosine started at 0 and cosine starts at 1, and then it's alternating 1, 0, negative 1, 0, 1, 0. So it's always, every other one is 0, and then it's every other one is 1 or negative 1. So for cosine, every other one is 0, and then alternating 1 and negative 1 also. And then for tangent, it's 0 and then undefined. And then for cosecant, it's undefined and then 1s, alternating 1 or negative 1s. And then the same thing for secant. And then cotangent is, you know, the opposite of tangent, so undefined and then 0. Okay. So I'm going to move to the next slide. So we graphed a sine last time. I've just included this first column. I made it sideways, but here our numbers are. And here are our values, right? So at negative 2 pi, we should be at 0. So I'm going to put a little dot there. And then at negative 3 pi over 2, well, let's talk about this. This is negative pi over 2. This is negative 2 pi over 2, which is negative pi. So this right here is negative 3 pi over 2. And we're at positive 1 right there. So I'm going to put a little dot there. At negative pi, oops, this should say negative pi. So let's fix that to say negative pi. This should be 0. And at negative pi over 2, this should be negative 1. And then at 0, we're at 0. And then you see the pattern, right? So here we're going to go up, 0, down, 0, up, 3 pi should be back at 0, 7 pi over 2 is negative 1, and 8 pi is right there. And then this is going to be very bad, but you're basically going to, it's really hard to draw a sine curve with this thing, but basically it's going to look something like that, right? I'm going to erase it and show you exactly the good picture of it in just a second. Okay. So that's a rough look at it, and then here's a more professional look. So let's go to the next slide. Oh, but you know, first I have to delete all of this. So let's do this, and I want to erase all the ink on the slide, except I'm going to put this negative pi back. Okay, so now I'm going to say next. And I want you to notice that sine was 0 on the whole pi. So right, here's a whole pi, here's a whole pi, and here's a whole pi, and here's a whole pi, and here's a whole pi. So it's 0 on the whole pi's, and it's alternating 1 and negative 1 on the over 2's, right? So here's the over 2's, or the half pi's, right? Okay, so let's go to the next thing. So we're getting rid of that, and there is the actual sign, and here the dots are that I just put in by hand, and then here's, you know, a nice looking curve. So this is what I drew earlier, but this the computer drew, and it looks much better. Okay. So again, this is really important. Sine is 0 on the whole pi's, and alternating 1 and negative 1 on the half pi's, so the over 2's, right? Okay, next. So now we're going to do cosine. So here I have the cosine graph, and again, I guess on all of these I did not make that a negative pi, so I'm going to have to fix that so it's a negative pi on all of them. Probably on the first screen it should be a negative pi also. I'm not going to go back and fix that, but it should be negative pi on the first if it's not. Okay, so it looks like here, let's see if we see a pattern. It's 0 this time on the over 2's, right? So at all the over 2's or the half pi's, it's 0. So that's the opposite of sine, right? Sine is 0 on the wholes. This is 0 on the halves. And then it looks like alternating 1 and negative 1 on the wholes. So I wrote that down, so right there, I think. Yeah. So notice that cosine is 0 on the half pi's and alternating 1 and negative 1 on the whole pi's. Alright, so now again we're going to graph this. So at negative 2 pi, we're at 1, so a dot. And then at negative 3 pi over 2, we're at 0. And then at negative pi, we're at negative 1. And then at pi over 2, we're at 0. And at 0, we're up here at 1. And then hopefully you can see the pattern, but at positive pi we're at negative 1, and then 0. At 2 pi we're at 1, and then 0. And then here at 7 pi over 2. Oh, you know, I'm using my mouse instead of the... This probably will make it easier. I didn't realize I was using my mouse instead of this. Oh, see, it's so much nicer not to use my mouse. Okay, anyway, and now I'm going to try to draw this. Again, it's, you know, a little difficult on this, but it's going to look something like this. Okay, so then you connect the dots and you draw your cosine curve, and you know, drawing on paper it's going to look a lot better, but again I have a professional one coming, so let me just erase the screen. And I'm going to go to erase all ink on slide, but I'm going to put this one back, and then I'm going to say okay, get rid of that. So got rid of it, and look at that. There is the nice version. Okay, so yours should look something like that. Good job. Okay, so now we have some notes, so I'm gonna click the notes. Why aren't you clicking? Oh, there. So last time, remember, we asked, when I was with you, we asked if the sine or cosine function could ever be greater than 1. And I remember that Nairi said that no, it couldn't be, because remember, sine is always opposite over hypotenuse, and since hypotenuse is the longest side, then there's since the hypotenuse is the longest side, then the opposite over the hypotenuse this number would always be the bigger number, so that's always going to give us something that is smaller than 1. So we know that sine and cosine are smaller than 1. But what about cosecant and secant? Well, cosecant is hypotenuse over opposite. So the biggest side's always going to be on top, and the same thing for secant, it's going to be hypotenuse over adjacent, and the biggest number is always going to be on top. So that looks like it's always going to be greater than or equal to 1. It's never actually going to be between -1 and 1. It's always going to be above the two lines. So there's that. And then when does a function have vertical asymptotes? So remember we learned about that, and that's when the denominator is 0. So when the denominator is 0, that's when we have vertical asymptotes. And for the trig ratios, remember, those are only undefined when the denominator is 0. So the trig ratios have vertical asymptotes where they are undefined. So that would only be for tangent, cotangent, secant, and cosecant. So for sine and cosine, there's no vertical asymptotes because it's never undefined, but all the other trig functions, the other four, will have some asymptotes, and that's wherever it's undefined, there's going to be some vertical asymptotes. Okay? So next. So when does cosecant have vertical asymptotes? Well, cosecant is the opposite of sine, right? So it's whenever sine is 0. So sine, remember, is 0 at the whole pi's. So that means that cosecant would have vertical asymptotes at the whole pi's. So at the whole pi's. Okay, so cosecant has vertical asymptote at the whole pi's. And you know, this is a Greek letter pi, so it's pi, not pie, like the pie that we eat. Okay, so it happens, cosecant would have vertical asymptotes anytime that sine is 0, and sine is 0 at the whole pi, so that means cosecant has vertical asymptote at the whole pi's. And secant would have vertical asymptotes whenever cosine is 0, and cosine is 0 at the half pi's, so that means that secant has vertical asymptotes at the half pi's. Oh no. So this is at the half pi's. Okay, so now we're going to graph cosecant. I wrote it up here so we know what we're graphing every time, right? So we're graphing cosecant, and it says it right here also. And remember, this is negative pi. So it looks like we're going to have asymptotes at these whole pi's. So at negative 2 pi, I'm going to try to draw a vertical asymptote. You don't always have to do that. I'm just going to do it this one time just so that you guys see how it works. But as a rule, you don't really have to draw these asymptotes. But I would have asymptotes here at all of the whole pi's. And a couple more, and then we'll be good. Okay. All right, so now let's see what it says next. So we have these vertical asymptotes. Okay, now the easiest way to graph this is to make the asymptotes, which I did, and then we're going to graph the sine function as a dotted line, and we're going to put parabolas at the peaks. So let's go ahead and do that. Looks like I didn't finish this asymptote, so let me finish this asymptote. Okay, so remember sine. So I'm not looking at these right now, I'm just looking at what the sine looks like, remember? And sine looks like this. So right here. Did I skip one? 1, 2, up. Yeah, this should be here. So sorry about that. Okay. And let's see, I want to erase 0, 1, 0, 1, 0. So this one I want gone. 0, and then I want gone. Okay. Okay. So back to the pen. So then and then 0, and then there. No, it shouldn't be there. And then here it'd be down, and then 0, and then up, and then down. So remember, sine is going to look something like this, but I would of course draw it okay, so this is sine. Let's change colors here. I think that's going to be too light. So now remember what I said. I said that we would have peaks. At the peaks we would have these parabolas. So that's what this is going to look like. So these are going to look roughly like this at the peak. So this one's below, so it's going to be pointing down. So the actual graph of cosecant is just these blue parabolas. So they're at the peaks. And then you're going to see that it looks a lot better for the professional one, which I'll show you in a second. But basically this is what it looks like. So at the peaks you draw your parabolas, and then these are serving as asymptotes, so the lines don't actually ever touch them. Okay, so let's erase all the ink on the slide. First of all, put this back in. Just remember it was negative. So that was negative, and then we'll advance, whoops, and then we'll advance. So we're going to slide that down so we have some more room, and then this guy's going to go away, and then we're going to hit the graph. So this is the actual graph of cosecant. It's the solid parabola looking shapes is the actual graph of cosecant. You just have the sign as a guide of where to put in your, where to start your parabolas. But then you can actually, so you don't have to draw the sign. You can draw it without the sign, so that would look like this. So here it is without the sign before it. Okay? So now we're going to go on to, you guessed it, secant. So again, the easiest way to graph the secant is to graph the cosine and graph the asymptotes, and then put the parabolas at the peaks. So this would going to look just like cosecant, except instead of the bumps being at the over 2's, the bumps are going to be at the pi's. So I'm going to graph cosine first. Well, first here's the asymptote. So the asymptotes are at the over 2's, right? So the asymptotes are at these over 2's, so that would be here. Where is it? So there we go. At the over 2's. Would be our asymptotes. And one more. And then if you notice, it's going to be 1. So after I graph cosine, so let me graph cosine. So cosine starts at 1, so and then this was up, so this is 0, -1, 0, +1. So remember, cosine looks roughly, very roughly, like this. And so then, you know, we're at the peaks, we're going to have the parabola-like things. But here, if you notice, it's +1 at -2 pi, so that means the peak starts here at +1. So it would look something like that. And then here, and then here, and here, and here. So if you wanted to graph this without, I think mine ends at 4 pi, so mine's going to end up looking like this. It's just going to have this half here because I graphed only, you know, I cut the picture of the graph off right here. And then this part's not going to show on the one that I'm going to show you. The professional looking one's going to look like that. But it doesn't matter. So if you wanted to graph this without graphing your cosine function first, you can. You just know that at 1 you're going to have an upwards parabola. At -2 pi you're going to start your upwards parabola at 1, and then at -pi, at -1 you're going to do your down parabola, and so on. Okay, so let's clear the screen. Okay, and then we're going to do the advancing. So right here, I'm going to slide this down so we have some more room. There we go, it's coming back. There we go. So here is secant. And again, remember I said we were only going to see this part, but if I went past -2 pi, then you would see this part over here. And over here you'd see this part. Okay. And next. And there it is without the cosine curve first. All right. Now tangent. So tangent has asymptotes at the pi over 2's. So again, at the pi over 2's, we're going to make some asymptotes. And then tangent looks like a cubic function. So tangent looks like this, roughly. It looks a little like the cubic function, and it just keeps repeating. So it's going to look like this. Really like that. And so it just looks like the cubic function. It always goes through right at negative 2 pi. At the whole pi's at 0, so at these whole pi's it's always going to go, you know, right through here. And then the pi over 2's are serving as its asymptotes. So there we go. Okay, so that is what tangent looks like. So you just have to remember tangent looks a little bit like the cubic function. Here's a better looking tangent for you to see. Oh, I want to clear the ink. Okay. So it's 0 on the whole pi's and the asymptotes at the half pi's, which I already said. And then keep going. It's going away. There it is. And there is a better looking tangent than the one that I drew by hand. Okay, so now what's left is cotangent. In cotangent, the zeros are at the half pi's and the asymptotes are at the wholes. So let's go ahead and draw those. So the asymptotes are at the wholes. And then at the half pi's is where it's 0. And now cotangent looks just like tangent, but instead of going this way, it's backwards, so it's this way. So that way. Ooh, that was an ugly one. And okay. Good. So now let me show you a good looking one. So tangent 0 on the whole pi's and asymptotes at the half pi's. I already said that. Oh, I forgot to erase the ink. Let me get rid of the ink. And there we go. There is a good graph of cosecant. Or sorry, cotangent. Now, on all of these, I showed you how to draw the asymptotes, but really you don't have to. I just wanted to show you that actually that they're there, but when I graph them, I really almost never draw the asymptotes. I just keep in mind where they would be when I draw it. Okay? Oops, sorry about that. Okay, so thank you very much, and be nice for the sub, and I hope you understood this. Thanks. Bye.